about something called transversals. And I don't know that you guys have ever heard that term before, but it's just a new vocabulary word. So nothing to worry about. It's actually quite simple. It's simple vocabulary, which much of mathematics is actually vocabulary. So what a transversal is it a line that intersects two or more other lines. Okay, so here I've drawn a pair of parallel lines, and I'm going to cross it with a transversal. So this is my transversal. And you'll notice that my transversal creates several angles. I'm going to do some of them in blue. So we can say we have angle 1 and angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, and angle 8. So I drew the red angles with red because I wanted to show that those are what we call interior angles, because they're inside the two parallel lines. And the blue angles we would call exterior angles. Okay, and because we have parallel lines, we have some specific types of angles that are created by these parallel lines. So we have corresponding angles, and you can start filling out your chart. Actually, I'm going to just change that to white, sorry. Not white chalk, white pen. Corresponding angles, I'm just going to use the angle symbol. Interior angles. Alternate exterior angles, and should be actually alternate interior angles. And exterior angles. And then alternate exterior angles. Okay, so our corresponding angles are angles in the same relative position. Same relative position. All right, so for example, angle 1 and angle 5 are in the same relative position because angle 1 is on the top side of the parallel line to the left of the transversal, as is angle 5. Angle 5 is on the top of this line and to the left of that line. Angle 1 is on the top of this line and to the left of that line. So there are more corresponding angles than just those two. What are some others you can see? Well, angle 4, Angle 4 corresponds to angle 8, doesn't it? And angle 6 to angle 2, and angle 3 to angle 7. So we have a lot of corresponding angles. I've already kind of shown you the interior angles. The interior angles are the angles in between the parallel lines. Okay. I'm going to put between the parallel lines. Okay. Alternate interior angles are angles 3 and 5 are a good example of alternate interior angles. Angle 3 and angle 5. So let's look at those. The way I've numbered them, I numbered them differently than I did in my own notes, so it's actually not 3 and 5. It's actually angle 3 and angle 6. Okay, so alternate is a key word. So here's angle 3 and there's angle 6. So see how they're on the opposite side of the transversal? So angle 4 and angle 5 are also alternate interior angles. Okay. The exterior angles are angles that are outside of, whoops, I'm going to switch back to yellow. Angles outside of the parallel lines. So our examples are angles 1, 2, 7, and 8. Those are all exterior angles. And alternate exterior angles, I bet you guys can guess what those are. They are on the opposite sides of the transversal, but they are exterior to the parallel lines. So an example would be angle 1 and angle 8. Okay. So the other thing to note is that alternate exterior angles are equal. So if we knew the measure of angle 1, it would be equal to the measure of angle 8. That same goes for the alternate interior angles. The measure of angle 3 is equal to the measure of angle 6, for example. I should have put that down here. Okay, so the measure of angle 3 is equal to the measure of angle 6. Sorry, I'm running out of space. All right, so pretty much lesson 97 is a lesson about vocabulary. So there's a lot of vocabulary to learn, and you're going to be asked numerous questions based on those vocabulary words. Lesson 98 is geometry as well, for those of you who like geometry. And it's talking about the sum of the angle measures of triangles and quadrilaterals. And I know we have already discussed how many degrees are in a triangle. It's been actually quite recent. Then we've also talked about supplementary and complementary angles. If you'll recall, supplementary angles add up to 180 degrees. Okay, and that's why I draw that S so funny. It's like two 90-degree angles, right? Whereas complementary angles add to 90 degrees. All right. So that polygon there I've drawn is parallelogram. And it says if we extend the polygon to form an exterior and an interior angle. Angles 1 and 2 are also supplementary, okay? Angles 1 and angle 2, are supplementary. So recall from lesson 90 that a full turn is 360 degrees, okay? It's basically a full circle, right? So, and we saw a picture of it, that these turns really correspond to the exterior angles of polygons. So, for example, if you were saying I ran and made 4 turns, okay, that means that you turned 4 times. Okay, we would know that each turn was 90 degrees because you made a full circle, and 360 divided by 4 equals 90. So we know that each of these turns is 90 degrees. Okay, and my next thing says if the exterior angles of a triangle average 120 degrees, so let's draw the triangle that I have drawn. And what we're saying is that these angles are 120 degrees. Then, how many degrees must the average interior angle be? Well, we know that these two angles are supplementary. So we know that 180 minus 120 equals 60. And so this angle here would have to be 60 degrees. And therefore, the sum of the interior angles of a triangle is 180. And the sum of the interior angles of a quadrilateral is 360 degrees. And now I want you guys to turn to page 526 and do the practice problems on that page, and we'll go over them. And we will begin filling out little tables such as this, where we've been given either a fraction, a decimal, or percent, and we are expected to change it from that to the other two forms. I'm going to use green for my blanks. All right, so 1/2. How would we write 1/2 as a decimal? Well, there's more than one way to figure it out. Probably you have it memorized, but you can think of it as money. What is half of $1? 50 cents. So how do I write 50 cents? Like this. And I could write the extra 0 on the end, like that, but I really don't need to. We normally write it as 0.5. And then when we go from a percent to a decimal, how do we do that? Well, if you recall, we multiply by 100, so we move our decimal to the right twice. And we end up with 50%. Half of something is 50% of it, right? What happens when we start with a decimal, though? When we start with a decimal, it's probably about the easiest we can get, because it's pretty easy to change a decimal to a percent. We just move the decimal point over to the right twice. 1, 2, multiplying by 100, and we get 30%. Okay, the other going from a decimal to a fraction is quite easy as well. We simply have to read this using not the word point, but avoiding the word point. We can read that as 3/10. So we can just write it as a fraction that way, 3/10. And sometimes you'll have to reduce them, and I know you're fully capable to do that. So what happens when you start with a percent? Well, when you start with a percent, we know we can just divide by 100 because percent means per hundredth. So if we divide by 100, then we're moving our decimal point to the left twice. And so we can see that it's 0.4. And once again, we can look at that and read that as 4/10. But 4 and 10 are both even numbers, so we can reduce that by dividing each of them by 2, and we get 2/5. Let's do a few more together, and then I'm going to let y'all do the rest on your own. So you're going to see lots of charts like these, and if you struggle with these, there is some supplementary in the practice in the back of your book that you can use to improve your skills at it. So 3/5, there's more than one way to change 3/5 to a decimal. We could come over to the side and divide 3 by 5, like so. Okay, and 5 doesn't go into 3, but it goes into 30 6 times. 6 times 5 is 30, so with 0 left over. So we can just stop there and write it as 0.6. The other way we could have thought about it is we could have thought, well, I can change this to tenths pretty easily by multiplying by 2 over 2, and I get 6/10, and I know how to write that as a decimal. It's 0.6. All right, now we change it to a percent, and we do that by multiplying our decimal by 100, and so we get 60%. How about 0.8? If you already find this very simple, I'd like for you to stop the recording and do the practice problems on your own. I'm only going to go through letter F so that y'all can do G through L on your own, and we can go over it in our lessons. 0.8 as a fraction would be 8/10. 8 and 10 are both even, so we know they can both be divided by 2. So when we reduce it, it becomes 4/5. And then we multiply 0.8 by 100, and we get 80%. 0.8 is pretty close to 1, isn't it? So, okay, 20%. Written as a decimal, we divide by 100. So we move our decimal to the left twice, and we get 0.2. And writing it as a fraction, it would be 2/10. We can divide each of those by 2, so we get 1/5. All right, finish up those practice problems on your own, and we will cover them in our lesson together. Lesson 100 is about algebraic addition of integers. So what we need to do is review some of those words. So what are integers? Anyone? Anyone? Okay, integers are counting numbers, their opposites, and 0. So integers are counting numbers plus their opposites and their opposites plus 0. Okay, so looking at our number line, we could put dots at these integers. 0, 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. And if our line kept going on and on, we could continue on with those numbers. So So the next question is, what numbers are not included when we talk about integers? Well, it's these numbers in between, okay? So -4 1/2 is not an integer, okay? So it's only the whole numbers, they're opposites, or the counting numbers, they're opposites, and 0. All right, so now imagine that the temperature is 0 degrees. So let's draw ourselves a little thermometer. I've learned how to use this thing, kind of. All right, and here is our thermometer. Okay, and let's imagine that the temperature is 0 degrees. Okay, so here's my 0. Ten, 20, 30, 40, 50 degrees. What falls below 0? Well, -10 degrees. So we don't ever get that cold in Texas, but some places do. So imagine the temperature is 0 degrees. If the temperature falls 5 degrees at 12 a.m., then falls another 5 degrees an hour later, what's the resulting temperature? Well, here's my in-between. So it goes down 5 degrees, and then it goes down 5 degrees again. So my ending temperature is -10 degrees. Now, how could we write that as an equation? So it starts at 0, and then it goes down 5 degrees, so plus a -5 degrees. Then it drops 5 degrees more, plus -5 degrees. So when we look at the thermometer, it's kind of easy to see that it's -10, but when we look at an equation, it can feel a little bit confusing, but we're going to be adding positive and negative numbers now. So you can see when we add two negative numbers like this, our result is a negative number. We add them together and our result is negative. Now imagine the temperature is 0 degrees. If the temperature falls 10 degrees at 12 a.m., so let me erase these lines here. So it says the temperature falls 10 degrees at 12 a.m. but rises 5 degrees before sunset, before sunrise. So it goes down here and then it jumps back up 5 degrees. Well, the result is -5 degrees. Now, how could we write that out as an equation? Well, it started at 0, then it went down 10 degrees, and then it went in the positive direction 5 degrees because it went up. So anytime temperature goes down, it's in the negative direction. Anytime it goes up, it's in the positive direction. So the result would equal -5 degrees. So by this example, we can see that when we have a negative number, let me change colors real quick. When we have a negative number added to a positive number, we end up subtracting. And the result, the reason this is negative is because 10 is bigger than 5. All right? Since 10 is larger than 5, it takes the negative. So let's look at our notes again. It says, when we add numbers with opposite signs, the result is the difference of the two numbers. In other words, when you have different signs, you subtract. And the sign is determined by the larger number. So now let's hit some of our examples. We have 8 plus -5. Okay, so our signs are different. 8 is positive and 5 is negative. But, so that means we subtract. We find the difference. We subtract. When we subtract, we get 3. And is it going to be positive or negative? Well, it's going to be positive because our 8 is larger than our 5, and our 8 is what's the positive number. Let's look at the next one. We have -5 plus -3. I'm going to put the -3 in parentheses because we normally do that in order to separate the two signs. So here we have both have the same sign, so that means we add 5 plus 3 is 8, and they're both negative, so it's going to be negative. If it was 5 plus 3, we would add, and our answer would be positive because both are positive. So if the signs are different, we subtract. Okay, and the sign is determined by the larger number. If our signs are the same, then we add. Okay, and sign is the same as numbers added. Okay, let's do a few more examples. If we have -6 plus +6, that would equal 0. If we have +6 plus -6, well, once again, the signs are different, so we subtract, and 6 minus 6 is 0. So we don't have to worry about the signs on those. If you want to think about it in terms of a number line, you can, if you're struggling with this at all, please draw a number line. Don't let your pride be your downfall. Draw a number line, and this is how you can picture it. Let's do -10 minus -6. So if we start at 0, here's 10. And here's -10. All right, so this is how we would draw it. We're going to go from 0 to -10. Now this one's kind of tricky because if we're going to subtract -6, it's just like saying I'm not going somewhere, because we have two negative signs. And when we have two negative signs together like that, we need to do, they essentially cancel each other out. And if I say I am not going to the park, that means I am going to the park. Works the same way in math. We want to add the opposite of 6. Well, what's the opposite of 6? It's +6. Okay, so since we went to -10, now we have to go 6 in the positive direction. So 1, 2, 3, 4, 5, 6. We end up at -4. Okay, and you can see we have a +6 and a -10, so we have to subtract. 10 minus 6 is 4. Well, 10 is larger than 6, so it gets the negative sign. And that's the only double negative I have for an example. So now let's do another one using our number line. -3 minus +5. Okay. First thing I want you to see is that this is the same as negative 3 plus negative 5. Okay, in algebra we like to use addition because you can do addition in any order. So here, if we're just going to solve it by using our mental math, we would say, well, our signs are the same. They're both negative. And we already said if signs are the same, we're going to add. Okay, so we know we need to add these. 3 plus 5 is 8. Well, both signs are negative, so it's a negative 8. Okay, now let's show it on the number line. So we start at 0 and we go in the negative direction 3. Okay, that's negative 3. And now we're going to go negative 5 more. Which leads us 1, 2, 3, 4, 5. Negative 8. Okay, that's how you can use your number line. Always be ready and willing to use your number line whenever you're doing these kinds of problems. Please finish up these practice problems on your own, and we will definitely go over them together.